10, Section 5, Segment Lengths and Circles. The first theorem in this section says if two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. A picture of this would be having a circle with two chords intersecting on the interior. I'm going to go ahead and the point where the two chords intersect, I'm going to label A. I'm going to label E. So I have chord AC and chord BD that are intersecting at E. Notice where chord AC could be split into the segments AE and EC, and chord BD could be split into the segments BE and ED. What this theorem says is that the product of the two segments is going to be equal to each other. So in this case, I would have AE times EC would be equal to EB times ED. This first example says chord AB and CD intersect inside the circle. Find the value of X. Well, chord CD is split into the two segments measuring 12 and 9, and chord AB is split into two segments measuring 18 and X. What I can do is I can say 12 times 9 equals 18 times X. Well, 12 times 9 is 108 equals 18X. I need to divide both sides by 18 to solve for X. And when I do so, I get X equals 6. So that would be an example of that last theorem that we talked about. The two segments of chords, when they intersect each other, the product of the two segments created are going to be equal to each other. In this diagram, I have a circle, and I have a PR would be a secant segment. So all the way from point P to point R, we would call that a secant segment because notice it's crossing the circle at 2 points, and then it's going through the circle from point P to point Q, but then it's going to stop on the circle at point R. The blue highlighted segment would be called the external secant segment. And then if you look at the yellow segment, we have a tangent segment, PS. Remember, a tangent line is going to extend in both directions and be a line. A tangent segment is going to have endpoints. One of those endpoints is going to be on the circle, the point where it intersects the circle. This next theorem says if two secant segments share the same endpoint outside a circle, then the product of the length of one secant segment and its external segment is equals the length of the other secant segment and its external tangent segment. So we can take the two secant segments, split them up into its external segment, and we can multiply the whole secant segment times the external segment, and we're going to be able to set them equal to each other. An example of this, I would have the two secant segments AC and AE. AB would be one exterior secant segment. AE would be the other exterior secant segment, and I can say the whole secant segment AD times the external secant segment AE would be equal to the whole secant segment AC times the external secant segment AB. An example of this asks us to find the value of X. The first thing that I need to do here is find the measure of the whole secant segment. Notice I have the two secant segments, FD and HD. Well, if you notice, FD would be split into the two segments measuring 10 and 11, so the whole secant segment, DF, would be 21. And similarly, for DH, I have the two segments 12 and X, so I need to add those together. So the whole segment, secant segment DH, would be 12 plus x. The external secant segments would be 11 for DE and 12 for DG. What I need to do is I need to find the product of 21 and 11 and 12 plus x and 12 and set them equal to each other to solve for x. Go ahead and multiply 11 times 21 and distribute your 12, and you get 231 equals 144 plus 12x. Subtract 144 from both sides and you get 87 equals 12x. And when you divide both sides by 12, you get 7.25 equals x. The next theorem says if a secant segment and a tangent segment share an endpoint outside of a circle, then the product of the length of the secant segment and the length of its external segment equals the square of the length of the tangent segment. An illustration of this, I would have the secant segment AC and the tangent segment CD intersecting at point C on the exterior of the circle. The external secant segment would be CB, and this theorem says that for this example, I could take the entire secant segment CA, multiply it by the exterior secant segment CB, and set it equal to the length of this tangent segment CD squared. This example asks us to find the value of x. Notice I'm given the tangent segment AB is equal to 30. I'm given, I have a secant segment AD. I'm given that on the interior of the circle, that segment would measure 24, and on the exterior of the circle, that exterior secant segment would be x. I need to find the length of the entire secant segment, which would be found by adding 24 plus x, the two segments creating the larger segment, AD. What I can do is I can say x, the exterior secant segment, times x plus 24, which would be the length of the whole secant segment, equals 30 squared, which is the tangent segment, AB. Go ahead and distribute your x and square your 30, and we get x squared plus 24x equals 900. What I'm going to do now is something that hopefully you will remember from Algebra 1. I need to solve a quadratic. I could solve it by factoring if I wanted to, and if it was possible here, which it's not. So I'm going to have to solve this by using the quadratic formula. I'm going to go to the next slide to solve this quadratic using the quadratic formula. The first thing you need to remember is that the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, and that's all divided by 2a. I'm going to rewrite the quadratic that we had from our previous slide. So we have x squared plus 24x minus 900 equals 0. To use the quadratic formula, I need it in standard form and set equal to 0. So this is going to work. For my a, b, and c, a would be the constant in front of your x squared, which there's an understood 1 there, so 1 would be a. My b would be 24. And my c is going to be negative 900. What I need to do is I need to take that formula and plug in 1 for a, 24 for b, and negative 900 for c. So I'm going to have negative 24 plus or minus the square root of 24 squared minus 4 times 1 times negative 900, all divided by 2 times 1. Go ahead and you need to do what's inside of your square root first. 24 squared minus 4 times 1 times negative 900 is going to give you 4,176. So I have negative 24 plus or minus the square root of 4,176, all divided by 2. What the plus or minus means is that this quadratic is going to have two different answers. One when we take negative 24 and we add the square root, and one when we take negative 24 and we subtract the square root. But remember here, we're talking about the length of a segment. And when we are talking about length or distance, we're not going to be able to have a negative distance. So we have to take a positive answer here. One of the answers that you get for this example is going to be negative. One of the answers is going to be positive. We only need the positive one for this question. The positive answer that you get when you plug this into a calculator is 20.3, which is found by adding the square root of 4,176 to negative 24 and then dividing by 2. The next example says you are standing 18 feet from a circular display case. The distance from you to a point of tangency on the case is about 32 feet. Estimate the radius of the display case. So notice I have my circular display case. It tells me that I am going to be represented by this blue dot, and I am 18 feet away from the display case. It also tells me that I'm going to have a point of I'm going to be standing 32 feet away from a point of tangency of this circle. They ask me to estimate the radius of the display case. Right now, I don't really have a way to solve this problem, but I do need to go ahead and draw in the radius. And when I draw in the radius, I'm actually going to draw in the diameter, which creates a secant segment using the diameter and my distance from the display case, which was 18. When I draw in the diameter, I'm going to label this as R and another R, because remember the diameter is made up of 2 radii. So my secant segment here would be R plus 18, which would be 2R plus 18. The external secant segment would be 18, and then my tangent segment would be 32. This secant segment and this tangent segment are intersecting at the point where I am standing. So what I'm going to be able to say is that my full secant segment is 2R plus 18, my external secant segment is 18, and my tangent segment is 32. I can say 18, the external secant segment, times 2R plus 18, which is the whole secant segment, equals 32 squared, which would be my tangent segment. Go ahead and distribute your 18, and you get 36R plus 324 equals 1,024. Subtract 324 from both sides, and you get 36R equals 700. Divide both sides by 36, and you find R to be about 19.4 feet. Today's assignment is on page 632. It's numbers 3 through 28.